surveys. One is one that I always get, and I forgot to give it to my first class today. But this one is a survey, and I'll just tell you what it is. We have that video option now. See, our pros from Dover there, the AV crew on steroids back here. They are, so we have a video option for this class, but it's kind of makes it a low residency class. You got to come in for the exams, you got to come in for the labs, but you can stay at home and just kind of watch it on YouTube whenever, on YouTube, Kansas City, whenever you feel like it. So here's what I want to do. I want to pass out a survey that asks questions like, I'm taking the 5:30 class because, 1, I work, 2, it's the only one that fits in my schedule, or 3, the lab fit my schedule best, those kinds of things. And if I had a choice, would I do the live lecture? Is it live or is it Memorex? So they don't even do tapes anymore. All is digital now. But anyway, so pass that on around. Just take that, pass it back. And if you could do the same. Pretty soon here, I'm going to start giving the quizzes and passing things back, so I won't have to say if you could do that. I wish we all had name tags or something, but we don't. Hello, my name is. So go ahead and do that survey real quick. Take about 5 minutes. The lecture today will run till about 6:29, I think, or so, to get through what we need to get through. We will finish chapter 1, and we'll. Now you do have mastering. How many of you have gone and bought the textbook? Okay. How many of you actually went paper and paste type textbook, or just went strictly ebook? Oh, okay. My other class, quite a few. I was surprised at the number that actually bought the book. But now you do know that if you buy the ebook, it goes away after 2 years. You have no more physics book after 2 years that you can access. Now, of course, within that next 2 years, you could always go to the ebook and print it off. It'd probably cost you close to $100 in printer cartridge by the time it was done. So you got to look at it that way too. All right, but anyway, okay. So go ahead and take that little quiz real quick, or not quiz, survey. Are you all done already? Is everybody done? Even the people in the back that just now got it? Okay, I'll take it. I'll take it back. So far, so good. I'm not irrelevant yet. Oh, good. I thought I was going to be totally irrelevant by the time this was. Oh, yeah, we just. Okay. All right. And the rock chalk. All right. Of course, they're going to sit in the back. I would too if I was wearing a KU t-shirt. Kidding. I went to Mizzou, so class of '83, even though I started in '71. But come on in. No, I didn't start in '71. All right. Now here is a little like learning styles thing that I want you all to take, and it's kind of fun. Just remember, it's one of those things. This is kind of like for my. It's not going to go to any research or anything like that yet, and your answers won't. But go ahead and remember, when you're taking something like this, it's your first impression. Don't try and outthink it. Don't try and say, well, what are they asking? What are they really asking? It's on mathematical learning styles, which is about the same for physics and stuff like that. Okay? So go ahead and take that. And again, since it's a survey, I can't ask for your name. Otherwise, I'd give everybody a... Oh, that's what we'll do. Then the last thing I want you to do is I want you to once you get done with that, I'll give one more thing, because we got our horned frog has to leave. All right, so I want to make sure that she gets credit for coming in today. Where did that come from anyway? A horned frog, vice what?
Well, they were digging out the football field because they wanted the chapel to be the highest point on campus. So they dug the football field so it would be lower. They found a horned frog, which is actually really a lizard. It's not a frog.
Right, it's a horny toad.
Yeah, horny toad. Yeah.
Right.
They found one
Okay.
Lying around, and so they decided to call them.
Oh, okay. Yeah. Interesting. Okay. Are you all done? For the most part? Okay. You all done with that thing? Okay. And I got kind of like one comment to make about this too. Or not a comment, this is a suggestion. All right. Oh, can I have one of those? Can I have a blank one? I forgot. There should be some back here. Is there a blank one back here? Thank you. All right. Okay. Now then, here's how you score this survey. At the top of the page, put an O for odd and an E for even. Now count up your odd answers. Put that number, of course, with odd. And then count up your even answers and put the number of even answers that you had under even. All right. How many of you were all 12 were odd and no evens? Oh, 1? Okay. 12, 0. How many of you were 11, 1? Oh, man. Okay. How many of you were 10, 2? There is no right answer. Oh, quite a few. 1, 2, 3. Okay. 10, 2, 3. How many of you were 9, 3? 1, 2, 3, 4. How many of you were 8, 4? 1, 2, 3. Okay. How many of you were 7, 5? Or 12. 7, 5, 2. Okay. 6, 6. How many CEOs do I have out there? Future 1, 2, 3, 4, 5, 6, 7. Wow. Okay. How many of you were, we'll get through this here in a second, 5, 7? Because it starts to go down here. 1, 2, 3, 4, I think, right around there. That's quite a few, actually. 4, 8? None. 3, 9? None. 2, 10? 1, 2, 10. 1, 11? Anybody want? Oh, wow. Anybody 0, 12? Which is where I was. Okay. Now, all of you here and above, out of the 1, 2, 5, 9, 12, 13, 20, there's about 20 here, and then 7 over here. You 20 did school very well. That's the way they taught you in school. Do things by the numbers, step by step. That's why you like to do things. And it's fine. There's nothing wrong with that. We all need accountants and everything else. How many of these folks over here were like artists or graphic arts or like art and those kinds of things? No? Okay. Well, here's the deal. I was way over here. I was 0, 12, and my wife, the opposite, is 12, 0. Odd type 1 type learners are the ones who like nice algorithms, step-by-step ways of doing things. We'll do the first problem. We'll go on to the second problem. When I taught in high school, I could always tell my type 1 learners, because they're the ones, as soon as they got stuck on something, they'd raise their hand, and they wouldn't go on until you answered their question. Okay? Then they'd go on, and then they'd be fine. Your type 2 learners, your even type people, they might even start with they were very random, and they wanted the big picture of why am I doing this, and also your type 2 learners, your even learners are the type that if you give them 15 problems to do, they'll do problem 3, 8, 12, and 16 and go, okay, I know how to do this. Why do I have to do the rest of them? Whereas you guys over here, you're kind of little people pleasers. You'll do them all, and turn them in, and everything. Especially those up here, you know exactly how much is in your checking account at all times. Okay, right? The 3 over here, you change banks. Okay? Just go, I have no idea. Next paycheck, I'm opening a new account. And this time I'll keep track, I promise. I'll keep track. Okay? Little details don't bother you too much. That's why I'm saying these are the future CEOs. These are the people that kind of want to see the big picture, but at the same time need a good plan on how to get there. Okay? All right, these are the people that plan in detail. These are the dreamers, kind of. And these are the people that are good in geometry. That's why I asked if there's any art and stuff. And so, guess who pays the bills and keeps the checkbook in my house? My wife does, so she's right up here. And she's also, it struck me that she was so strong this way because she's also a musician, but she's a percussionist and a singer, but anyway. So, anyway, the whole point of this is those of you that are up here, my teaching style might drive you batty for the first couple weeks, right? Because I have a tendency to go, okay, I think y'all see the big idea. You can figure out the rest. You can figure out the details on your own. Then you'll go and you'll start to read a homework problem. You'll go, wait, I need a little push in the right direction. So what I try and do is always do some homework problems to each class period. So there we go. We've got our surveys done, and you can keep that thing. I don't need to collect it. But from now on, you'll just know if you've got someone who's very organized and by the book and does things in sequence, you like those classes. Classes that seem like he's making it up as he goes along. Kind of drives you nuts for a little while, but you'll get the hang of it. Anyway. All right. So today we're going to cover chapter 1, where we learn all about what physics is, how to take a measurement, do unit analysis, and do some problem solving, and do some conversions. We all like to do some, so there'll be some conversions. So right now what I'm going to do is, I remember there's a third thing I wanted to do. Since this is my smaller class, okay, you're going to take your quiz right now. And here's your first question, first and only question. Get out a sheet of paper or a half sheet and put your name on it. And I'm going to put 5 points for quiz 1 or 10 points for quiz 1 in the grade book. And then I'm going to pass them back on Tuesday, and that way I get to interact with you all and learn your name. Okay? You video people, you don't get a quiz. Losers? No. But anyway, some of you signed up who said you'd prefer to take the video class. It's not too late. If you want to see me after class and jump on that bandwagon, you're more than welcome to do that. Okay. And I'll explain to you how it works. Right now, it's not being loaded to YouTube as we wanted it to. Okay, so go ahead and put your name on it. Put your name in the middle, then the top, right-hand corner, I don't care. Remember, I'm Mr. Random, so it doesn't matter. And I'll collect those now. Yeah, that's it. That's the only question. There we go. Go ahead and pass them kind of down to the middle here. Like this group, pass them on down to Don. See, I'm smart, I'm quick, I can pick things up. Okay. Thank you. Thank you, thank you, thank you. This is kind of a big class. Thanks. All righty. Okay, and what about the Jayhawks? Are we going to pass? Oh, okay. All right. Okay. Looks good. Thank you. Thank you. And I'll make sure I score these. And first quiz. Done. See how easy that was? All right. Now, let's go to the laser light show. Do I need to, I'm going to turn off the lights. Do I need to turn on the overhead projector and shine my face even though I'm going to? What did that mean? Cut. Oh, did I get turned off? No sound? What? There we go. Is that okay? All right. I don't know what she was meaning there by some of those pantomimes. Okay. Oh, I need to turn on everything. Gosh, dang, I was getting ready to show the slideshow to myself there. I've already seen it. I liked it so much I bought the video. No, or the DVD. But I have hit modern times. My wife and I actually signed up for Netflix, and we were able to actually do it. It worked. It took us a while. It took us a couple hours to figure out the web page and everything, but eventually. Is that flashing?
It's still red.
It's still red. There we go. All right. Now then, slideshow from beginning. There we go. We're going to start. Oh. Can you see me on the thing? Am I coming up? All right. Okay. College physics. I can do this. First thing we're going to do is move this over here. There we go. All right. Now, that's what your textbook looks like. You all know that. All right. Chapter 1. What we're going to do is measurement and problem solving. That's going to be the name of this first video. Okay. Now then, what I want y'all to do is sometimes physics is like art. Okay. You just got to let it flow over you. This first 15 minutes, there's no need to take notes or anything. And this is just kind of the esoteric part. All right. And so there's nothing. There we go. Now just stay awake. So if you need to take notes, to stay awake, you can't. All right. So what we're going to talk about is measurement, problem solving. But first, we're going to talk about what physics is, and why and how we measure, and units of mass. This is basically what we're going to be discussing today. All right. Basically, physics is this. Physics is the study of nature. Okay. That's what we do. We're trying to figure out how nature works. It's the most basic of sciences. Okay. The chemists might think that they've got the corner on the basic science, but actually it's probably physics. And the only difference between chemistry and a chemist and a physicist, chemists are physicists who don't like math, basically. All right. So actually, that's you can erase that part in case that gets out. But anyway. What we do is we attempt to describe nature in an objective way through measurement, as it says there. And we basically use, we do use the metric system in this class. Now, how many of you have taken your physical chemistry or your chemistry 1 and 2 or Chem 1, or have had chemistry? In chemistry, you deal a lot in grams, calories, all that kind of stuff, right? We deal in joules for energy and kilograms, all right? That's our unit of mass. It's kilograms and meters. And we use the metric system. We don't use the British system. Okay? All right. Units of length. Length, mass, time are the fundamental quantities. All right, and what we do is we have to take a measurement so we can quantify things so that it makes sense. Okay? So that things make sense. All right. Here we go. Our basic unit of length is the meter. All right? And they used to have, well, they still do, they have this like gold meter stick in the museum or the Museum of Weights and Measures in Paris. Okay? Because they first figured out that they took this distance here from the North Pole through, of course, dead white guys ruled the world, so that's what they said. There's go through the Greenwich meridian here down to the equator, and that turned out to be 10 million meters. And they divided that by 10 million and said this length is going to be a meter. The problem with that is when they got that, they measured that thing off to be exactly a meter long. Well, it's made out of gold and platinum, I think, or something like that, or iridium or something. And what would happen if you took that and it was a really cold day and took it outside to measure something? What would happen to it? It'd shrink. So it wouldn't be a standard anymore. There's one thing that is always a constant in the universe that never ever changes. And this will hold you in good stead for physics 2 also. And that is the speed of light. The speed of light never ever changes. It is always constant. Okay? It is 3 times 10, or this. This is basically 3 times 10 to the 8th meters per second. And so if I take that 3 times 10 to the 8th meters per second, take the inverse of it, that's what 1 meter is. It's how far light travels within this amount of time. Okay? Now that would 1 over basically 30, what is that? 300 million. Okay? That'd be hard to get on a stopwatch. Get a 300th of a millionth of a second. That'd be hard. But anyway, I don't think my thumb could move that quick. But so that's the actual what a meter is. It's how far light travels within that short of time. Okay? Because the speed of light is always constant. Okay. Next thing is a kilogram. Basically, it's mass. Now I know you all know the answer to this question, but let's get it out of the way right now before we get to forces and all that stuff. Is there a difference between weight and mass? Yes. Big difference. Mass is how much matter there is. How much stuff is there. Okay? How much stuff or how much matter there is in this subject. And one of the curious things is we really don't know what mass is, or we really don't know why things stick together the way they do. That's what the particle and theoretical physicists are trying to figure out with that big CERN. Have you heard about the big collider there in France and Switzerland? It's broke. They turned it on and it kind of went whoosh. They're going to smash some atoms together. Basically what they do is they send an electron zipping close at about 0.9999999 times the speed of light, and it smashes into another one coming the other way. Okay? And they're going to take all kinds of measurements on that thing, and that's the way they come up with on your periodic table, all those little elements at the very end, 114, 116, and all those that disappear within like 1/300 millionth of a second. That's the way they make new matter. They crash these protons together and they make a new proton. All right. But anyway, and when they do that, they're going to try and see what happened, what gave us matter at the very beginning of the Big Bang. That's the goal. Okay. The Hubble telescope has told us what happened about 400,000 years after the Big Bang. How old is the universe, by the way? Anybody know? Older than dirt. Yeah. It's about 13.7 billion years old. And if you need another science class that's not related to your major, but you just kind of want to bump up your science GPA and stuff like that, I highly recommend Dangerous Dan McIntosh's astronomy class, either 150, or if you've had a year of calculus, is 355. And then, lo and behold, you almost got yourself a physics minor. Okay? But anyway, and they look at all that stuff, all that astronomical stuff. But anyway, I got off track. Kilogram is how much stuff there is. And 1 kilogram, and it's different from weight, but we do say, because weight is how much force is being applied, according to gravity. All right? You take mass times the acceleration due to gravity, and there you have the weight. So, big question. Is our mass the same here as it is on the moon? Be careful with that question. Is our mass the same as it here as it is on the moon? Yes. Well, what about our weight? No. Okay. Because the moon has a smaller gravitational pull, so the acceleration due to gravity is a lot less. That's another weird thing. If y'all want to win a Nobel Prize, figure out what causes two massive objects to attract each other. Okay, vice the electrostatic forces that will, or electromagnetic forces that attract things together. We have no idea what causes gravity. We know it's there. We know it works. We don't know what it is. Okay, they're getting close, but no one's been able to tell me exactly what it is. All right. Okay. And if you figure it out, $1 million, Nobel Prize, waiting for you. That's the check you get. Okay. So there's another reason to get your minor in physics. Right? Okay, SI unit. 1 second. Basically, we've got this atomic clock, and we've got the Naval Science Institute of Technology or something like that in close, I think it's in Baltimore. Or it might be in Annapolis, actually. That makes more sense in Maryland. Anyway, did you know that right now, as you're sitting there, even though you're dying in place on me, some of you, I can tell, and I'm sorry, we'll try and get through this as quick as we can, that every molecule, atom in your body oscillates. It's oscillating, and it's oscillating at the speed of sound, basically, supersonic speed, right at the speed of sound. And the only thing that's keeping you from flying out that door with a sonic boom is that they're all going in different directions. So it's kind of keeping you all in one place. But everything, every particle at the atomic level oscillates back and forth. Okay? And they measure those oscillations. In other words, when this thing, the frequency of the oscillation, once this thing goes through one oscillation, which once it goes through, what is that number? Good grief, 9 billion times. Once it goes through roughly 9 billion oscillations, it does 9 billion oscillations in 1 second. That's pretty quick. All right. And that's what they call 1 second. Okay? So, one thing you can try and do is try and come up with a definition of time when you don't use time in the definition. See if you can do it. I haven't been able to yet. I can't figure it out. But anyway, here's our definition of time. All right. So now you've learned about all these things that will not be testable, but you might remember them, like your molecules all flying around at the speed of sound. Did y'all know that? Y'all ever been told that before? I didn't know that either until a year or so ago. Okay. And according to according to the laws of quantum mechanics then, maybe there is a probability that all your particles will accelerate in the same direction at one time and poof, you'll appear somewhere else. Okay? It could happen. Push on that wall and all of a sudden, poof, you're on the other side. Probably won't. But that reminds me of a physics joke. Okay? I should probably have you turn off the camera, but we'll do this anyway. there's a physicist, and then we'll break for commercial too after this joke. But anyway, there's a physicist. Every night, he came into this bar for about a week, and he'd order 2 martinis, one for himself and one for the empty bar stool next to him. Okay? And he'd sit there for a while, and he'd slowly sip his martini for about an hour, then he'd leave. And he'd leave that full martini sitting there. About a week of this behavior kind of went by, and the bartender finally asked him. He said, what are you doing? Why are you ordering 2 drinks, drinking one, and then leaving? He said, well, I'm ordering these 2 drinks because, and I'm having one, and I'm setting the next one down. He said, because due to the laws of quantum mechanics, due to the laws of quantum mechanics, a beautiful woman could all of a sudden appear next to me, just appear next to me. And the bartender said, that's crazy. Why don't you just ask a woman to come with you to the bar? And he said, what are the chances of that happening? So, anyway. Sorry. Okay. All right, no more physics jokes. All right, now then, we're not halfway through. We're a little bit over halfway through. But one of the things, like I've told you before, your brain is starting to melt down. So what do they do to you on television when your brain starts to melt down and they want you to pay attention? They give you a commercial, right? So that's what we're going to do. We're going to go to a commercial break. And the reason I came up with this was my daughter's 25. She's about you all's age, okay? And she's got her idea of what humor is, and she's trying to get me accustomed to what's hip now. Like, she gave me a DVD of the movie Superbad. I watched it, and I was like, yeah, all y'all are going, oh, that's the funniest. But after about 5 minutes, I was getting ready to just beat the snot out of that curly-headed guy, okay? I just couldn't stand him anymore. I was like, this is not funny to me, all right? She gave me so my wife and I actually tried to watch the movie Knocked Up. Again, I was like, and I asked my stepdaughter and my daughter, I said, if a guy ever talked to you like that, the way this guy talks to the Katherine Heigl character, I said, I would put a hit out on him, all right? I'd have his legs broken. But anyway, but then I figured out, oh, it's just a generational thing. Now, here is what old people think is funny, all right? I think the U2 baby is hysterical, all right? It's because I'm old, all right? But something that is funny, now this is your commercial break, we'll go to the E-Trade Baby outtakes. All right? Have you all seen these? Because you're not old. All right? So anyway, we'll turn this up. Oh, hold up. I got to turn it up. There's probably some kind of copyright violation I'm doing here because this is going to be on, because we're actually putting paid advertising on. Volume up. Let's go back. Real quick, does this take a minute?
Yo, what's up, people? I just thought I'd give you a little, sneak peek at some of the stuff that won't be making the big game this year. So, anyway, check it out.
First question, do you have a girlfriend?
Why? You interested or something? Oh, what did I think about the economy in 2008? Check this out. Benny still pays for a big, expensive broker. Well, he's a friend of my father's.
This baby right here.
Until just recently, I only used my BlackBerry to, just do emails and organize the occasional cuddle battle with a bad girl. You know what? I can't even tell you how I feel about all these Wall Street fat cats.
I want to punch the economy in the face.
The language I would have to use would be very inappropriate. Mom puts me in timeouts. Bullshit. Oh my God. Dude. So her online profile says she's 5'11", and I'm like pounds maybe.
Okay. All right. That's what I think. All right. We've had our commercial break. It was back to physics. Now, okay. when you all, we'll start from the current slide, so these are the basic standard units that we're going to be using. Okay, now, when you all go to the lab next week, you're going to take a little quiz. Know this chart. Know like what centimeters, 10 to the negative 2, milli. Know these guys, all right? And it's in your book, or it's on one of the pages, table 1.2 in your book. And you can get like kilogram, 10 to the third. Okay. All right, so when we use centimeters, we'll actually convert that to meters, and we'll do that here in a minute. All right. Which isn't too hard. All right, 45 centimeters. How many meters is that? 0.45, right? Yeah, you just slide it. Yeah, to the left. Sorry. I used to teach scientific notation at Don Bosco and stuff. We used to do, remember the old 69 Boys? The Tootsie Roll song? To the left, to the left, to the front. Y'all don't remember that? Yeah, okay. Anyway. All right. Basic unit volume. Y'all can read that. And it's on the thing. All right, now, let's talk about unit analysis, because here's where people get kind of screwed up with things. What we're going to do is we're going to talk about unit analysis. Well, I'm going to go through the slides real quick, and then we're going to do some actual problems, okay? When you do unit analysis, that tells us if the answer makes sense that we're looking at, all right? In other words, does this answer make sense? And, all right, so here's a question. Units may be manipulated algebraically. All right, so here's the first question. Is V equal V naught plus AT? Does that equation even make sense according to the units? Now, first of all, some of you have not had any physics before, so you don't know what we're talking about here. Basically, V is velocity, which we'll talk all about in chapter 2, okay? Kinematics, meters per second. This V naught is also meters per second. Now, does acceleration, which is meters per second squared, times the time, which is seconds, will this equation all balance out? In other words, will the units come out? And as you can see, they do. All right? They do. In other words, velocity is meters per second. V naught, which is the initial velocity, is in meters per second squared. As Ms. Crunchmeister taught you all in freshman algebra, right? When you got an s squared multiplied by s, it just turns into an s in the denominator. And so you don't worry that. Now don't get hung up on, well, this is equal to 2ms. No, we're just looking at the units. We don't care about quantity or anything. Just looking at the units. All right? And unit analysis can get really hairy in electricity and magnetism. Real hairy. Real quick. But it's still kind of a good thing to do. With us, for Physics 1, it's not so bad. All right, and we'll also look at some unit conversions. Here you all have been converting things since you probably took your first 9th grade physical science class, right? Had to convert inches to meters or centimeters and all that kind of stuff. We'll do a couple of those problems, all right? So we'll do some, Sig-Figs, significant figures. This is going to be kind of embarrassing on the camera, and I'll explain Sig-Figs in a minute. We'll get back to it. One of the things about Sig-Figs, I don't know how to define it and explain it. I mean, I know how to explain it, but I don't know how to actually define it. Do they just say it? Calculations, 2 types of numbers, exact and measured. Okay, so exact numbers are like D equals 2 times R, so that's an exact number. Significant figures is for a measurement. That makes sense, okay? And I'll show you how that works here in a second. Okay. All right. We'll go to and then the last thing we'll do is we'll do some problem solving. All right? The main thing with problem solving is this. It's all these 6 steps here. All right? And read the problem carefully and analyze it. All right? I get so many students come in and they've read the problem. Where appropriate, draw a diagram. We'll learn all about free body diagrams in this class. Write down the given data and what is to be found. Here's where people get lost. I don't know how many times I hear the question, or people come in and say, I don't know where to start. Oh, so we're stuck on step 3. We don't even know what we're trying to find, okay, because we're not familiar with the terms. Okay? I know how people that are new to a subject, especially in physics and in math, I know how they go about doing their homework. They don't bother reading the chapter. You go straight to the problems, and you go, ooh, which formula fits this? And you start going through the chapter that way, right? Try that backwards. Try actually reading the chapter. Take your time. Go, okay, I'm going to take my time here. I'm going to read the chapter, and it's amazing. It actually, well, I didn't figure that out until I was in grad school, all right, when I was 40. That's the way it worked, okay? Determine which principles are applicable. That's the real physics part. Perform the calculations. That's the math part. And consider whether the results are reasonable. Okay, so let's talk about all that stuff. So we did the conversion analysis thing, so we don't need to do that. The rest of the class will, the next 15 minutes, we'll just do some problems. Okay? The first one, we already did kind of the unit analysis, but let's see if this one unit analysis, this other problem makes sense. I never know where the thing is. There we go. All right. Let's do one more unit analysis to make sure that this would make sense. Let's say we've got something that says the velocity is equal to O t over 2a. Is that what they said? Let's just see if this makes sense. It may or may not. I don't know. Let's just see if this makes sense. Okay, so we know the velocity is meters per second. If you're kind of like, I didn't know that, don't worry. By the time we get through chapter 2, you'll be pros. Velocity is meters per second. Okay? And does this equal, unit-wise, seconds divided by, I don't really care about the 2 when I'm doing unit analysis. I don't care about the 2. And acceleration, by the way, is meters per second squared. In other words, it's the rate of change of velocity. I want you to kind of get that, start thinking about that idea of acceleration. Okay? It's how fast your speed is changing, or your velocity is changing. Okay? In other words, this is getting into chapter 2, but if your acceleration is 5 meters per second squared, that means after 1 second, you're going to be going 5 meters per second faster. So if you start at 0, you're going 5. At 2 seconds, you'll be going 10 meters per second, that kind of thing. Right? And so that is meters per second squared. Well, let's see if these two are equal to each other. So we've got m over s equals s over 1 times, you flip it, s squared over m. Thank you. Yes, it's been a while since I've taught freshman algebra, and I kind of got hung up there. Oh, none of this can't, oh, this is a mess. Well, that makes no sense. So this is an invalid formula to even start with. Okay. All right, so that's invalid. All right, that's good. All right, now, let's do a conversion problem. It's kind of fun here. All right, we started off, they had good old Noah's Ark. All right, think Noah, the story of Noah appears in Genesis 4. It's right after, there's a little bizarre story in there where you've got these alien giants come in and impregnate the women and then take them off. Have you all ever read that part? It's a strange little story. And biblical scholars sit there and scratch their head. They're like, what? What is this? But anyway, and then there's Noah's Ark, which is, everybody kind of knows the story of Noah's Ark. And anyway, he's got, the Lord came to Noah and said, I want you to build me an ark. course, as Bill Cosby said, the first thing Noah said was, "What's an arc?" And he told him, and said, "I want you to build it 300 cubits by 30 cubits by 50 cubits." Of course, his next question was, "What's a cubit?" All right, and basically what they found studying old Sumerian writings and things like that, and from that time, about, this writing was popular at about 4500 BC, right around then. They figured out that a cubit was right around 18, or half a yard. So 1 cubit equals 1/2 a yard. And what we're going to try and do is figure out what the arc is in meters cubed. Okay? Let's figure out what the arc is in meters cubed. All right. So here we go. First of all, I want to get it to meters. So yards doesn't help me much. Well, I could probably convert. As a matter of fact, 1 yard is how many meters? Do you know? It's almost the exact same thing, but not quite.
Yeah, it's like 3 inches short.
Yeah. As a matter of fact, 1 meter equals like 1.1 yards or something like that. But anyway, here's the deal. Let's go with centimeters then, because I know that 1 centimeter is equal to, or 1 inch is equal to 2.54 centimeters. I've known that for, seems like my whole life. I don't know why. I just know that one. And so a half a yard, how many inches is that? 18 inches. Okay, so let's start there. So what we've got is 1 cubit then is equal to 18 inches times 2.54 centimeters per inch. So the inches cancel, and I wind up with 1 cubit is equal to 18 times 2.54 centimeters, which actually comes out to be like 42.75, 45.72 centimeters. All right, let's convert that guy to meters. What would it be in meters? 0.4572. So right there, and so this is, so 1 cubit then equals 0.4572 meters. All right, now, so if you multiply this by 2, you get what a yard is, which is what, about 0.92 meters or something like that, as we were kind of discussing. All right, so now all I've got to do is this. Okay, full disclosure, I'm going to do something wrong here, and I want you all to tell me what it is. So I'm going to say, oh, well, Noah's Ark then is 300 times 30 times 50 times 0.4572. This would be right, because that's my conversion of cubits to meters. Is that correct, what I just did? No, what's wrong? It needs to be multiplied by each one. Very good. Exactly. In other words, I want cubic meters, and I just have 1 meter here. I can fix this with 1 stroke of the marker. There we go. Cube that guy. All right? And then it works. Okay? And what we wind up with is 43,000 6 meters. So the volume of the ark in meters cubed is equal to 43,006 meters cubed, which seems pretty big. And to the ancient people of Mesopotamia, that was pretty big. In other words, and whenever you read biblical writings, whenever they have a number bigger than 5 even, they mean no more than you can count, a whole bunch. That's just kind of the way, that's the way they quantified things. So this was about as big. This is like infinity to them. This is so huge, all right? But I did some checking. I thought, well, let's compare it to something modern, okay? Let's compare it to something modern. What's huge? I was trying to think of the hugest thing on the water that I could think of, and what I came up with was USS Ronald Reagan, all right, which is a huge aircraft carrier, all right? It's a huge nuclear-powered aircraft carrier. And the Ronald Reagan, USS Ronald Reagan, its cubic meters is this, 600,000. So it's quite a bit bigger than the mythical Ark. Anyway, so that's about the biggest thing I can think of that would float, and I don't think it would hold. It'd hold quite a few elephants and hippos and stuff like that, but I don't know if it'd hold every species in the world. All right. Okay, now let's talk about problem solving. We've done unit analysis. We did a kind of a hard conversion here. Oh, by the way, your assignment, your first assignment, you are getting graded for it, is due Monday. But if you don't, I know some of you are still waiting for financial aid and all that kind of stuff, so you can go get your books and stuff. You won't be counted wrong if you turn it in late. I'm just kind of want us to get going. So it's due Monday, and all it is how to do Mastering Physics. You'll go there, click on the assignments. It's a bunch of tutorials that you'll just go through on how to, like, you know, how to input scientific notation, how to do certain problems and stuff like that. So it's nice and easy. So just go to Mastering Physics, go to your first assignment. It's there waiting for you under the course, and it's due Monday. Give you something to do. Probably take you an hour, tops, to do. Okay? All right. And just like your first little quiz you took today, piece of cake. All right? It's your first assignment, so we're off and rolling. All right, let's talk about problem solving. All right? First thing you got to do is know what the problem says. Second thing you got to do is don't be afraid of calling on old knowledge that's correct, that you may or may not know. All right, so let's take a look at this. I was going to actually make this a quiz where, remember, my quiz is where we work together and stuff like that. All right, but we've already done the quiz. It was a hard one. So let's just take a look at this problem, and that'll be the last thing we do for the day. All right, so here we go. Here's a problem. I've got a chandelier. It's 1 meter this way. It's a 2-dimensional chandelier. And it's holding up a flame, or a candle. And this is 1 meter. And this is 1 meter. Oh, I forgot to mention something. Significant digits. I forgot to get to significant digits. Sig-Figs. Okay. Now, how many significant digits is this? So here, I'm going to teach it to you. We already know that exact numbers are like this, where circumference is 2 pi r. That's our exact number. That's a 2. Sig-Figs is for when we actually measure something. All right? And so when we actually would measure that thing, it'd come out, because this guy's a little irrational, it'd come out, we'd have to do the Sig-Fig. So I've got a question. How many Sig-Figs is that number? 4 or 2? All right. How many say 4? Okay. How many say 2? All right. Majority wins this time. Okay. This is 2 significant digits. All right. But, because those after that, but what about this guy? How many significant digits is that? 4. This one is 4. Now, I can turn this into 2 significant digits by using what? Scientific notation. Yeah, you chemistry people already know all this stuff, right? So it's 2.7 times 10 to the negative 2. Now it's got 2 significant digits. All right, so how many significant digits is this? 1. Yeah. I was going to say 2, but the AV crew said, no, it's just 1. So I'm going to go with 1. They keep me honest. Now how many are there for this number? 3. Right. Okay. There you go. That's all you need to know about Sig-Figs. Okay. And for the most part, when you read the problem, like if it says 3.81 meters, that means carry out all your calculations to 3 Sig-Figs, and then you'll get the right answer when you're doing your mastering physics. Okay? If it says 6.0, you can just carry it out to 1 Sig-Fig. I'd go to 2 since they put 2 numbers there. All right, but anyway, let's get back to our problem here. I had to take a detour there because I forgot to tell you about significant digits. Now we know all about them. The detour, or the problem is this. What is the height of that? Right there. And remember, we want the answer to be reasonable. And I'm going to tell you one other thing about reasonableness before we dive into this problem. When I used to teach high school math classes, or even, and you'd have junior high kids or something like that, or people that had bad experiences in math, and so let's go to the good old Pythagorean theorem. 3, 4, C. Okay? I know you've all probably seen that little internet. Now jokes fly around so quick, you know. But it actually did happen to me when I was teaching at the Hickman Mills Alternative High School. We had been doing the Pythagorean theorem for about 4 weeks, every day. It became a joke. The kids just thought it was kind of funny because there was always, during the class period, sometime we'd do a Pythagorean theorem type problem. Comes to their test. Gave them a test. The test was almost this very problem, and I said, find C. Of course, little Stephanie puts her finger on C and says, I found C. Now what am I supposed to do? True story. Anyway, but I also saw that in an internet, or somebody was putting out funny answers that they got on math tests. But anyway, invariably what happens when, here's what I mean by reasonableness of an answer. Invariably what happens is half the kids, when you're first teaching the Pythagorean theorem, will say, oh, therefore that side C is 25. You go, ooh, wait a minute. Are you sure? Does that make sense? Is that reasonable that 3, 4, that's 25? Oh, no. Oh, yeah. Take the square root. You have 5. Okay. So I threw that in there. 1 was because we use the Pythagorean theorem a lot in this class, because we're going to have to find magnitudes of vectors and things like that are going to be cattywampus at angles, and so we're going to have to find the x and y components to find the actual magnitude. Okay? So we're going to do a lot of that later on. But for right now, to find h, how am I going to find h here? What would be one way to skin this cat? Any ideas? Yeah. You can do that? That's a legal move? It's what kind of triangle do I have here? Yeah, that is a perpendicular bisector. Okay. Okay. What's your name again?
Brett.
Brett's saying, hey, use the Pythagorean theorem. We'll call this little part here d minus d squared equals h squared. That's basically what Brett is saying. And I said, well, what's d? Because here I've got a problem. This is a bad thing. when you've got only one equation and two unknowns, okay? Because there's infinite solutions here, all right? But Brett said, hey, D is equal to 0.5 meters. Is that true for an isosceles triangle? It is. It actually is. It's this guy. Thales' theorem. He's a Pythagorean. He hung out with, he's an OG, original geometer, okay? Hung out with Pythagoras. If you didn't like what you were saying, he'd pop his tongue at you, stuff like that. Anyway. So, all right. So, this is true. 1.0 squared minus 0.5 squared equals 8 squared. And so we come up with 1 minus 0.25 equals 8 squared. 0.75 equals 8 squared, which almost seems like a reasonable answer, but we take the square root of 0.75. And h is equal to 0.866. What's the last thing we've got to do? It's physics. It's a measurement. Units. You got to put units. That's what separates the men from the boys. Boys do math, men do physics. No, I'm kidding. All right. Okay. I think you'll be able to do, I think the problem solving type problems we're going to give you, they're kind of like little puzzles. Just, they're in the book, and there'll be like 4 or 5 problems, and I won't load them till Tuesday. I want you to get in there, do your thing, and then on Tuesday I'll give you a new assignment that'll be due like on the following Tuesday. Okay? Then we'll start doing give you like 2 to 3 problems for every lecture. Okay, did you have a question? No? No question? Any questions? All right. Go forth and prosper. Have a safe weekend. How many of you have class tomorrow?